Cool. So, trying out a new setup. Oh, also, Happy New Year. It's my first live build this year. This is exciting. It's a relatively new thing that I've been doing, but I'm hoping to do a lot more. And yeah, so if you're watching from Instagram Live, I am doing this on Twitch as well. And Twitch has, the Instagram Live feed. It also has like a much nicer microphone, and it has like an overhead camera view of the stuff that I'm working on. And it has like schematics, and I'm going to go over some other information as well with some of like my notes and the parts that we're going to be using. If you are in the Twitch, let me know how my levels are, just because I'm trying out a new setup. I have a new microphone, and it's also really loud in my studio tonight. There's like a lot of stuff going on. So I'm trying to like make sure I'm not. My Twitch is, I think it's just Brian period Oaks. Let me check. If I do this, please don't. Yeah, I'm Brian_Oaks on Twitch, and there's also a link in my on Instagram. Twitch, and there's also a link in my on Instagram. Twitch, and there's also a link. Oh no, I'm looping. But yeah, so there's a link in my bio on Instagram, and then otherwise it's Brian_Oaks at twitch.tv or whatever, however it works. Twitch.tv/Brian_Oaks. But yeah, let's get into it. So tonight we are building this circuit board. It's a VCA, which is also known, that's the acronym for Voltage Controlled Amplifier. So up until this point, we've built a VCO, a Voltage Controlled Oscillator, which is like a sound source. I don't have one in front of me, but I have a ton of stuff behind me. Maybe I'll pull one out later. So VCO is like an oscillator. Sine wave, square wave, triangle wave in the audible frequency, tunable, playable, automatable, has a CV in. And yeah, that was the first build we did. That was so we could sort of get a sound source, right? Second build we did was a VCF, which is a voltage controlled filter, so that we could sort of start, adjusting and shaping the waves from the oscillator that we were building. And I figured the next logical thing that we should go to is a VCA, a voltage controlled amplifier, to sort of complete the VCX trifecta. And so what is a voltage controlled amplifier? A voltage controlled amplifier is basically the simplest way to start automating volume levels or things of that nature when it comes to like modular synthesis. So you can imagine that a VCA is sort of an adjustable gate, something that can open or close, and something that you can have a sort of variable range of opening and closing. So similar to, using a filter and automating it with pulses or something like that, I could say with a sequencer, hey, at this step, let the sound coming out of my oscillator be at this level. At this step, let it be this level, and so on and so forth. And it's just sort of an easy way to, get rhythm, have things opening and closing at different levels in different times. It's a very, very versatile utility, really key in, modular synthesis, like I said. In my rack, this is my quad VCA. And yeah, like you can never have enough of these things. They're so useful when it comes to automation of sound internally. And so this one, what's really cool about this one is it uses something called an OTA, which is an operational transconductance amplifier. Um, so in a lot of my other circuits, I use something called an op amp, which is basically the cousin of the OTA. An op amp is a voltage controlled voltage source, so it lets us, uh, you know, control how much voltage is coming out of another side using like a gain, or a potentiometer or a resistor or whatever you want to do. Whereas this one lets us control the current coming out of the other side, um, and that's helpful in this because uh, we're using analog signals, we're using audio signals, and so a lot of OTAs are sort of like nobody really uses them. They're kind of out of touch because of digital audio processing. It's sort of like put these out of fashion, so to speak. Um, but I'm just going to start jumping into this build. It's not a very complicated build. There's a lot of like weird niche resistor values that I have to use. But other than that, it's pretty straightforward. So I think this might be a relatively quick one. So I did a little bit more research on like the actual history of these parts and stuff, so we could talk about that. But yeah, I'm going to jump into it. I'm going to start with the capacitors. Um, we're using some 470 nanofarad ceramic capacitors. Really simple, really common little guys. Um, and I'm just starting with these just because I only have the four that need to go in. Normally I start with like resistor values or something like that, just because they're very low level. They're like literally like their physical objects are very close to the board, make it a little bit easier to uh, continue to fill in components. Um, yeah, and ceramic capacitors are very, very simple um, as far as purpose too. Well, they're not very simple, but they sort of are like, you can think of them as like batteries. You can think of them as ways to reduce noise. You can think of them as ways to hold charge. They have many, many, many different applications. I feel like I'm still learning new ways that capacitors can be used, which is really cool. Um, so now I'm going to move on to 1K resistors, which are in this circuit are just for the LEDs. They're not really actually part of the circuit. Um, so if you're on Twitch, I have the schematic up on screen, uh, and you might notice that the schematic kind of looks like it's got a repeating pattern, um, and it does. It's actually because that this circuit is, it's basically like a double circuit. There's two of the exact same thing repeated, and each one of those itself is a double circuit. So this is actually like 4 VCAs all built into one. Um, so each one of these chips that I'll get into a little bit more when the time comes, each one of them lets us do 2 separate VCAs. Um, and so I figured the fastest way to sort of, well, I also had space on the board when I was making this one. So it was kind of like, it was practical and functional and kind of formal. I kind of like how populated this board gets when it's built. Um, cool, those are done. I'm gonna move to 12Ks. So I feel like this circuit, this was sort of in the running for um, where's the other, here it is. Running in whether or not I was going to build a VCA or a clock divider, because one thing that we're sort of missing from the boards that we've built so far is like, oh, hold on.
When you're drawing them, do you already know like what function it's going to have?
I kind of go back and forth a lot. Like, I think this is really different. This is sort of like, I'm thinking more of it like a sketchbook, even though it's the same circuits.
Mm-hmm.
So like, this is sort of a system that I can make these sketches as, if that makes sense. So like this circuit for this like yellow one is the same as this circuit that's behind this.
Uh-huh.
And so like I can have like 3 or 4 of them here and like sort of patch stuff around. And then I could be like, oh, I like this sound. I want to turn this into one of these collages. And then I do it all, like all the design and the drawings on like a software. And then I can kind of move the drawings back and forth between like Rhino and like 3D modeling stuff. So I can make like a million. Here I have like,
And are the sounds recorded or it's just like the pure sound that's like
it's the sound of like the electronics, yeah.
yeah.
Yeah, so I can like make drawings and then like, this is this one. And then like these are the other ones that I'm working on right now. This is like what this one's gonna be. And I can just do like a bunch of iterations before I even make them.
That's awesome. Wow.
Yeah, and then the sounds themselves are like just the sort of like analog components like working together.
Mm-hmm.
So this one's like an oscillator that's like done six times, and then I have like 2 more that are gonna come up here, and then like filters. This is just like a big mixer, some VCAs is what I'm building right now.
So when it's like displayed, are you able to interact with it, or is it reactive, or is it just a system that like continuously cycles?
I don't know, because I haven't displayed any of them yet. This is all like really recent work.
Yeah, yeah.
So I don't know. Like I've only really sold like one of them, and the guy who I sold it to, like his kids play with it a lot.
Oh.
So I guess it's interactive. I don't know. I'm like fine with it either way. I like haven't really thought about that. I am working on like some other things that are gonna kind of like accompany them. That'll be like just like solar panels mounted on the wall,
Mhm.
and like that'll make them like light reactive.
That would be really cool.
Yeah, and then I'm
That would be
thinking of
really
like
awesome.
an installation that would have like some of them on the wall and some of them maybe like output to lights, and then the lights of those being output interact with other ones.
Ooh.
And then this thing behind it is
Awesome.
like
They're like talking to each other.
yeah, yeah. And then
That's
this
really
thing is like a big like mixer automated thing that I'm trying to work on eventually too. Because I had another idea for a show that would be like a bunch of these all feeding into this like one sort of like sculptural box,
Mhm.
and then the box would be automated, and so like there would be speakers everywhere, and you would kind of like randomly hear one of them, and then it would fade out into another one, and it would all just be automated, and you would just like hear all these crazy sounds everywhere. I don't know.
No, this is definitely some really potent things to work with. That's really cool. I don't know anything about this shit, so if I ask a stupid question, I'm so
No,
sorry.
no,
but-
no.
Yeah, no, my ex was like super into like this kind of stuff, so I've been around it.
Yeah. Yeah, I feel like it normally looks closer to like this, like the
Mhm.
sort of this way of making like music, is it's like that, and then there's like a bunch of like patch cable spaghetti everywhere.
Wow. How long have you been doing this now for? Like at least a year, right?
About a year, yeah. I think I got my first circuit board made like,
Was it like RISD when you did that?
well, I was making them by hand. I was making like these sorts of things where I was like, you know, hand making the circuits,
Yeah.
and then I was using the resin printer at
Oh.
yeah, so this is all just Sharpie lines actually. Like I would do Sharpie and then etch it.
No, that's fucking crazy.
And then like the UV resin printer at Coworks I would just use all the
This
time.
drawing is so cute.
Thanks. It's like much bigger
Sorry,
pen.
illustration language.
No,
I'm
yeah.
just like everything's cute, essentially. Cute. Everything is cute.
Oh, that's illustration language.
Yeah, because it's always like, oh, that's so nice, or that's so cute.
Technical illustration term.
Wow, cool. Well, I have to go and feed my cat, but I see you soon here.
Yeah, I'm sure you will. I'm here like every weekend.
Sick. That's what I'm trying to do. I work every day from 8 to 4 this month, so
Oh my god.
I'm like trying to be more disciplined and like come.
Yeah.
Because like the last studio I had, I like never went. It was like so much more expensive. That was like more of a shit show though. That's another story for later.
Yeah, yeah.
But yeah, we'll catch up sometime.
Cool.
Maybe this week. Oh, well, if I go to Boston this weekend, then not this weekend, but.
Okay, I'll be
see
here.
you.
Bye. Okay. I am back. Where was I? Sorry, I got very distracted. We have so this is like a shared space, my studio, and so a friend of mine just moved into the studio that's like connected to ours, and because of COVID, like I can't really see anybody, so I haven't seen them in a really long time. So there's a little impromptu studio visit for you. I wonder what that sounded like. I can't imagine the mic picked up much of it, but cool. So I'm still working on resistors. I don't really know what I was talking about. I'm pretty fried. I was at my boss's studio all day today, so I'm a little spaced out. I don't know what resistors these are. I just picked them up. I'm gonna figure this out. What resistors were these? Were these 12Ks? No. Were these 47Ks? I think so. They have the green and purple. Yes, these are 47. No, these are 4K7. Cool. Sweet. Oh, nice. Hey, Zach. Hey, Will, in the chat. Thank you for joining me on this Thursday night. And anybody who's on Instagram, it doesn't tell me who's still with me on Instagram, but I can see who's commenting in the Twitch chat. For the one person who's on Instagram, this is also being live streamed on Twitch. I can turn my mic volume up a little bit now. Yeah, sorry, it's a little loud in my studio, so I've been really kind of finicky with my mic volume. Normally there's not that many people here, I think just because of COVID, honestly. But slowly more and more people have been kind of coming through as the sort of glimmer of potential hope lingers on the horizon in COVID world. It feels like COVID world and like election world and media world, it feels like they're all separate. I don't know. Does anybody else get that? Bomani here. Who's Bomani? Bomani is here. Yeah, okay, so let's see. So what did I just pick up? 27Ks. So yeah, like I said, these have some really weird values resistor-wise, very specific. And because I really like controlling like all the formal aspects of these circuit boards, I've sort of opted for just, you know, scavenging online to find these really weird resistor values instead of just combining resistors and having a lot more stuff going on here. Felt like this was just like the better way to do it aesthetically. So I'm still on the resistors. Next I'm going to be doing so Will's in the chat saying resistors with symbolic shapes. 100,000 ohms is the shape of an elephant. 100 ohms is the shape of an ant. Instead of just color-coded is the next product line that would actually save people's lifespan. So I totally agree. So what Will's pointing out is that resistors, let's see if we can get them to focus. I don't know if we can. Pull down a little bit. So resistors, you can't really see, but resistors have little stripes on them, is what he's talking about. Let me see, where's the camera here? Yeah, so I don't think it's going to focus. Can't really see. But yeah, so resistors have these little lines on them. And there's two types of resistors that are really common. There's blue resistors and there's kind of beige resistors. And nobody knows why, and nobody can really explain why, but blue resistors have 5 bands, 1, 2, 3, 4, 5 bands, and like beige resistors have like 4. And the bands are color-coded and they correspond to what value this resistor has and what its, you know, percentage of efficiency is. So this resistor, for example, sorry, I bumped the mic, is a blue resistor, and it is red, purple, black, red, brown. And so I've been doing this so much that I kind of know, or I just have memorized that, oh yeah, so it's also the first 2 bands on blue resistors tell you what the numbers are, and then the third one is the multiplier of 10. So I know that red is the number 2, purple is the number 7, black is 0, and then red is, I think, times 10. So this is like 270 times 10. This is a 27K resistor. So maybe it's times 100. I don't remember. I'm not going to do the math. But yeah, so when you're first learning that, people have printouts, people have all these things, and there's no real way to like remember it other than just doing it a million times and using the same values over and over again. So I know that, like, you know, if I see yellow and purple, I'm dealing with a 4K or a 4-7 something something. If I see brown and then like a black band, or yeah, brown and then a black band, I'm dealing with like a 100, like a 10K or a 1K or something. Right now I have a 27K, and the last 27K is right here. It's really taken a while. Glad this isn't a long build. So now I have 22K, another very specific, resistor value. 22K. I'm just gonna kind of zip through this real quick. But yeah, so if this is your first time seeing one of these streams, the point is, or the premise, I suppose, and then the point is that I've been building, I don't know if you can see it behind me on the Instagram live stream, this thing over here, this sort of like white panel with these circuit boards on it, and this thing up here, and this thing over here, and I guess in some way this thing. I've been building these circuit boards, and I build these circuit board collages where I take a bunch of core components and I mount them all to a panel, and then they all run together, and there's lights and blinking things, but the main thing is that they produce sound and sort of like a sonic music arrangement type thing that's based on the components that it's built of. And it's all analog, so that means that the components, the transistors, the capacitors, the resistors, the things that you hear coming out of it, the audio you hear coming out of it, is solely based on the properties of the analog components, which means also that like the physicalness of them comes into play. If I'm working in a really cold studio, it's going to sound different than if I'm working in a really hot studio. But so yeah, so it's like there's just like a lot of things that I need to build, a lot of components that I need to build, and I really enjoy kind of sharing this stuff with people. And so I figured this would be a cool way to, I can't really have an art show right now because of the pandemic. And so this feels kind of like, obviously it's not an art show, but I feel like it's a way to sort of engage with a community similar to how artists that maybe give artist talks do, but this is like way more based on the kind of thing behind the curtain that happens, which I always think is really interesting. I think it's something that doesn't really exist in the art world very often. You have so many artists who have like major production teams behind them that kind of like always go unspoken for. And I don't know, I don't really admire when artists pretend like they are the sole creator of something. I think it's very selfish and silly and naive. People are asking questions in the chat. So, what is it? It's Bomani said, curious how you built/refined your skills with analog electronics. I'm struggling through building more analog circuitry, especially sound circuits, because it feels like there are so many EE skills to learn, DC offset applications, etc. So that's a really, really good point. Honestly, I think, like, I feel like I still don't really know most of that stuff. Like last night, I sort of relearned what a conductance amplifier is, which is the chip that we're using. I sort of always forget like how they work, and even still, like trying to really think about the physics of how these like analog things work. Whenever I look online, people always say don't get hung up on the physics because they don't really make sense. It's sort of like, this is a current or a voltage controlled current amplifier, current source. And that doesn't really mean anything because like you don't really control current, voltage causes current. So it's like kind of this weird thing. So it's like, just don't think about the physics. I feel like if you think about the physics, you get kind of tripped up in it. the thing that I really enjoy doing, and I think the thing that has helped me learn a lot about this stuff, is watching other people talk about it. And there's one YouTuber, this guy, Christian, like Blasol or Blasadol or something like that. I don't remember his last name, but he does this series called Modular in a Week. If you just search up like on YouTube, like Modular in a Week, he basically like, and a lot of the circuits that I use kind of come and are based off of his stuff. He turned me onto this circuit, which I have the PDF for as well, that I went out and like kind of sought out myself afterwards. And I really like hearing him talk about it because he doesn't talk about it from a physics perspective. He talks about it from like a functional perspective and like a sort of trial and error perspective. So like he, is a novice, much like myself, and will go and be like, oh, like I did this and it didn't work at all, or like I did this thing and like it didn't work at all. So like ignore this one part of the schematic or something. And I don't know, just like hearing people talk about, why they did something, or why something worked and didn't work, I think that's like super valuable when it comes to learning this stuff. Because yeah, like I still don't really understand. So these circuits, a lot of them use, most circuits you think of like have like a positive and negative voltage, or like positive and ground or something like that. Like if you're working with a 9-volt battery, one side has a little plus, one side has a little minus. We know that DC current is polarized, and a lot of these circuits, and certain circuits like this, they need to have a positive 9 volts and negative 9 volts, and then a ground in the middle. So like, or sorry, it's 12 volts. So it's positive 12 volts, negative 12 volts, and a ground in the middle. So from the positive 12 volts to the ground, you have a 12 volt difference. But from the positive 12 volt to the negative 12 volt, you have a 24 volt difference. And like, I still don't really understand why that is or why it works that way. But yeah. Oh yeah, thank you for Blasol. That's what it is. Yeah, thank you for posting the link to the YouTube channel in the chat. Yeah, his stuff is great. I love, like, when I'm looking for new ideas, I'll kind of like scrape through his Modular in a Week channel and see what circuits I haven't tried and see if there's anything cool. Yeah, I think one of the next things I'm going to build is probably going to be either based on his quantizer or based on his ring modulator, because I don't have a ring modulator yet. But yeah, like his channel is really good. The channel Look Mom No Computer used to do a lot more like tutorial style stuff. I feel like he still kind of does it, but he's been doing like kind of his own thing like this, where he's building his own like modular system. Oh yeah, thank you, Kelly. Yeah, on Instagram, Hackaday is a great community and resource for folks who actually build circuits and don't necessarily care about the theory or commercial optimization. I totally agree. They have an article that's about like just the CMOS chips, which for those of you that don't know, CMOS chips are sort of like a set of ICs, which is an integrated circuit, which are like the little black bugs that you see on circuit boards. And they have a series on like CMOS, like logic-based music, which is just like the fastest way to get a little tiny simple oscillator running and screaming and going nuts. And that article is really good. Maybe I'll post that in the chat in a second if I can find it, as soon as I'm done soldering. But yeah, Hackaday is another really great resource. And I feel like they feature a lot of really cool like artists too, who are like kind of getting involved in electronics and circuits. Yeah, Hackaday is a really cool one. Yeah, let me see if I can find that real quick. Yeah, they also, I think, have one. think they also do one about, yeah, logic noise. Was this it? But yeah, they work with a thing called a Heck-Schmidt trigger. I think it's some really cool, really simple things coming out of it. Is this it? Yeah, the 4106. Cool. Let me throw this in the chat. Yeah. Also, if you don't know Kelly's work, I highly recommend it. I'm a huge fan of Kelly's work. Yeah, incredible, like huge inspiration of mine. Seriously, really, really incredible, like biomimicry style circuit sound genesis. Yeah, really cool stuff. A lot of thinking about ways in which circuits and electronics sort of mirror like our brains and synapse, and what's the difference between, how a capacitor and a resistor fire off electrons versus like the way that a bird's brain tells it to sing a certain type of sound. Yeah, if you don't know that work, highly recommend it. I'll post a link to that as well in a moment. Let's see. Yeah. Oh, yeah, and Music from Outer Space. Geez, yeah. Music from Outer Space is another great one. Yeah, actually, I have here somewhere. Is this a Music from Outer Space? Yeah, so this is the book that I have that talks about the chip that we're going to use, the LM13700. It's called Make Analog Synthesizers, and it's written by Ray Wilson, who I think he runs Music from Outer Space, or is like one of the main guys there. Yeah, let me pull up Music from Outer Space. They do really, really, really cool stuff. Very, very cool. Very old school. Yeah, that's a great one. Okay, cool. Let's keep going with these. Yeah, so I'm just pulling one of these capacitors out because I was touching on the other one. But yeah, so I think what I was saying earlier, before we had a little impromptu studio visit, is that I was sort of between building a VCA, which is what we're building now, and building something with an LFO in it. And an LFO is a low frequency oscillator. The VCO that I built before is a very similar sort of thing. It generates some sort of like wave shape. But an LFO is much more commonly used for like tempo or, like sound automation in like slow time, I guess I could say, like, because oscillators are essentially like, pulses moving at such a high frequency that it blends into a sort of like audible signal and it gives off a tone. Whereas LFOs, you can kind of like hear them going like click, click, click. And that's really great for like tempo. So like these right here. I don't know if you can see that. The sort of yellow-ish orange blinking lights here. These are two LFOs that are just sort of like going at like, a much slower tempo than if that was to represent like an audible frequency or something. World radio history. I don't know if I know that actually. World radio history. Whoa. Documents the history of radio and TV. Oh, wow. Oh, this website is so good. It's got like the repeating like newsprint paper pattern. Cool. I have not been on this website. Thank you for that. Really cool for radio. Yeah, I didn't really think of that. I've been thinking about like maybe trying to do, because now that I'm starting to like amass a sort of collection of these circuit collage pieces, now I'm trying to think of how they should sort of be like maybe displayed in a space or something like that, which is not something that I've done yet. I haven't really gotten to show them because I started making them at the beginning of 2020. And so I'm thinking about like, maybe some sort of installation where there is radio, like they are connected to radios, and the sound coming out of one gets hooked up to a radio of another, a radio receiver of some sort, and maybe like then it becomes like a lot about like transmission. I used to make these works when I still lived in Providence, that were sort of based on like nuclear fusion reactors, and they had radio systems built into them. They had these like very special radio NRF chips inside of them so that they could wirelessly communicate. And I always thought of like, I feel like there's some sort of like conversation that could be had about the way that radio sort of like invisibly permeates a space, much like sound, just at a different sort of like range. And also like, the invisible radiation that comes off of like sort of nuclear devices and objects and things of that sort of nature. I feel like there's something to be said there. Yeah, so I've just sort of trimmed the resistors. Now I'm gonna just sort of finish soldering them. Also, let me, for those who are on Twitch and not on Instagram, let me throw this in Twitch. Yeah, cool. I'm really excited to look at the radio website. That's really sweet. Let me kind of hurry along here. We're coming up on an hour. A lot of nice little distractions tonight. But yeah, what I keep start saying and then stop saying is that one of the other circuits that I'm probably just going to do next is a clock divider, because I don't have, for these big circuits, I don't have just a standalone LFO module, which would be something that I could use as sort of like a heartbeat for the general collage that can figure out the timing of everything and the tempo and the pacing of the heartbeat. The defier of whale or squirrel. But yeah, because I have these other types of modules called a clock divider, and the clock divider has an LFO built into it. And the reason I like the clock divider is because instead of giving me one standalone tempo, it gives me a tempo, but then it also gives me a bunch of other pulses that are in some ways related to that one. So this device right here is my clock divider for my modular system. And you can see here's the thing that's blinking this orange light. I don't know if you can see that. And then all the white lights below it are the sort of like divisions. So it counts in binary, which means it's sort of like on, off, off, yada, yada, yada. And I don't know, I feel like with just a clock divider, I have a sequencer. I have a couple sequencers on here. I don't really use them that much because I feel like I get so much out of the clock divider still that I don't really even need a sequencer. Like when I go to make drum rhythms on this, because I have a little standalone drum module here, I feel like a clock divider is really all I need because you get like for a very simple rhythm. Yeah, cool. So now I'm going to do these LEDs. I'm going to drink some water. And I'm going to check something real quick on these LEDs because I want to make sure I get the right polarity. Yeah, these modules, I got the polarity wrong on the LEDs on here. And so some of them are right, some of them are wrong, and I always forget. So I just need to check until I get my next batch of boards and have it corrected. And I feel like a reverse polarity on an LED is not a large enough reason to scrap the whole board. Especially when the boards have to fly on an airplane. Oh yeah, Zach just posted a link to Wavefarm. Yeah, their website is really great. I think they're super cool. Modern Electronics Master page. Scroll down to, for example, the technical section. You can access archives of schematics related to all kinds of electronics, for example. Oh, that's sweet. Oh, wow. Yeah, I can't wait to explore this website. Which one is that? Modern Electronics Master. Oh, wow, they have like technical books and stuff too. Bernard's and Babani, hobbyist and technical book for the UK, from the UK, from the field's leading publisher. Drake's Encyclopedia, various editions of the electronic directory going back to ... Sam's Library, a collection of technical books. Wow. Ooh, books from General Electric too. Wild. Ooh, that's gonna be fun. Okay, LEDs. Putting some lights on this thing. I think I've mentioned this in other streams as well, but I really like putting. Hold on. I really like putting LEDs on my boards when I can that don't do anything other than tell you that it's properly getting power. Because since these get just turned into components for like bigger collages, the sort of, when I'm testing them, I like to test them before I assemble the whole thing just to make sure, I don't plug it in at the end and then it doesn't work and I have 20 boards on this thing and you have to go one by one. by doing it this way, when I test them, even before I plug sound in, if the LEDs aren't working, I know it's just not getting power correctly, and I feel like that has saved me, like potentially maybe not hours, but I feel like it saved me a lot of time, probably hours overall, all accumulated. Yeah, waveform is super cool. I think they just moved their like headquarters, if I'm not mistaken. I don't remember where. I could totally be wrong on that. I could be thinking of someone else. Oh, Wavefarms, and then there's also Harvest Works, and I think one of them just moved. I could be wrong. All right, now moving on to potentiometers. These are really small potentiometers because the thing that you are able to adjust on this is very minimal. It's really just like adjusting how much the sort of gate is being affected by the voltage coming in. It's just like a sort of adjuster. I have made a couple of these boards where I specifically put in a higher value potentiometer, not because it helps it function better, but because it gives it like a really gnarly sound. It makes it like really growl. It gives it some really wild like sort of background bass notes. I think it's because I'm like overdriving the circuit or something. But I'm not really sure. I'm not really sure why it does that. I did it by accident the first time, and I thought that the circuit was bad, but it was actually just I had put the wrong potentiometer in. So my knob was like really good when it was in the range that it was supposed to be. So this is a 1K. I put in a 10K. So in the range that it was supposed to be, it sounded normal. But then as soon as I like cranked it all the way to one side, it went like nuts. Where? Okay, cool. Potentiometers are done. Let's keep getting through this. Next, I'm going to put. I really like to use IC sockets, just because I've also had like issues where before I had like a setup that was a little more serious like this, I feel like I was constantly accidentally plugging my pin headers in backwards when powering these things. And you know, when you're working with electronics that have plus minus power, you're working with like a 24 volt voltage difference, and in the case of these circuits, that's always enough to sort of fry my ICs. And so when that happens, it's way easier to pop a chip out, pop a new one in, versus having to desolder like everything, and then trying to like get it out, and it just kind of makes a mess. And these boards, I like to try and have my solder joints look semi-presentable, just because sometimes I'm, you know, if I'm using a board, these boards, I've made them reversible. So if I want to do it this way, the only component that isn't reversible, the only parts that aren't reversible are the ICs, because there's like, you know, a ton of pins. So I have to solder them on the reverse side of the board anyway. And so those are the only real components that end up having to get soldered upside down. And so, you know, if you have to desolder it, you've got your soldering iron on the board a lot, and it just kind of makes a mess. And I like to try and avoid that. So having an IC socket really helps in the case that I burn out an IC. I don't have to spend a bunch of time and make a huge mess on my board. But yeah, so while I'm preparing to insert my IC, I'll talk a little bit more about them. So I kind of said a little bit at the beginning that these are not op amps, which I use for a lot of these circuits. These are operational transconductance amplifiers, which are kind of like cousins to op amps. And so, op amps are voltage controlled voltage sources. So in a way, they're I don't know. If you think about like the function and the intention, they're kind of like what this circuit will do in the end, in a way, in a bit of a stretch, but yeah. So where op amps are voltage controlled voltage sources, OTAs are voltage controlled current sources. And so they're really good at processing analog signals. And this one that I'm using, the LM13700, is specifically meant for audio signals. It's kind of been like, it's an OTA that's kind of been souped up in that direction. So they're really great for being used for, I use another 13700 in my sort of like more complex VCO, because I have one that turns a triangle wave into a sine wave. And the circuit that I use that I added on to my original VCO that does that uses an LM13700. I've also seen people make really nice voltage controlled filters with them. All sorts of good stuff. I really, aside from my triangle to sine wave converter and the VCA, I don't really use them that much because they're a little hard to find. Just because the OTAs just aren't really used that much anymore. The age of digital audio processing sort of made them a little less popular, and then I feel like that kind of like trend just sort of slopes down very quickly. So most people, I feel like they're sort of forgotten. Put a potentiometer in series with a small current limiting resistor. Oh, yeah. I guess I could do that. I don't know. I kind of like the real growl of it when it does happen. I mean, now I use the right one, and I kind of avoid the problem that way, but I feel like it was a cool little characteristic that I was getting out of it. What's going on? All right, so ICs are in. I'm moving on to 1/8" jacks. Oh man, some of these holes are a bit too small. I did a big bulk order on these boards so that I could make a bunch of new works sort of all at once and not have to wait for boards to come in. And I think some of the quality on some of the boards got kind of skimmed on. That, and I think the components that I use are really cheap components, so sometimes they come with legs that are a little bit bigger than the holes that they're supposed to have. I think the combination of those two sort of compound each other. But yeah, after this, just going to put some power in, and then we'll be able to test it. So I think the next live build I'm going to do is going to be a clock divider, because those are really great. But I'm also thinking about doing maybe like a live jam, because a lot of people have asked me questions about my modular rack, which is still like a work in progress. And so I've been thinking about maybe doing like a sort of like live demo on it, and just sort of sit down with nothing patched in like it is right now, and just sort of, I don't know, see what kind of sounds I can get out of it. I use it a lot mostly for sort of sketching new collages that I want to make. but sometimes I use it and like we'll record it just as like music, as like sort of a demo. I haven't had too much time to do that just because of all the holidays and the artist that I work for, like during the day, has been moving studios, and so I've just been like working some wild hours there. Haven't had that much time to be here, unfortunately, but should be over soon. Which fab house? I use JLC PCB. JLC PCB. I mean I really like them. They like I feel like overall they're sort of like the fastest and the cheapest. And I really don't get like that many issues from them. I feel like we have a good little repertoire going. But I've also tried PCBWay. I liked their stuff. It's just like more expensive. And I feel like they don't have as many color options. But yeah, I like JLC PCB. They're sort of the first ones that I started using, and they're kind of the ones that I keep going back to. Try King. Ask for Spring. King Creddy. I don't know that one. Where are they based out of? Oh, cool. They do flexible PCBs too. Is this where you get your boards from? Yeah, I think JLC PCB is based in Shenzhen too. Gotcha. All right, so almost done with these jacks. Great. All right. The home stretch. Just gonna put some power cables on, and then we can plug this guy in. So I have my little cheat sheet here, but I don't have written down which side is positive. which side is negative? Let me pull this up real quick. Open up the board. This is VCA. Ooh, that's a really good question. How do you feel about artists who put electronic effects in their works without understanding how electronics work? I don't know. I think it really depends on what it is that they're sort of trying to like use or like utilize or showcase or exploit, or because I don't know. I think that like electronics art is already kind of like a very like gatekeepy, but I also think that like I guess it really is like similar to when people make political art that's kind of just like a surface level hot take, if that makes sense. So like if you're trying to make an art about or make some sort of artwork that's supposed to be about like a political movement or something, but the artwork itself sort of falls flat to people who like truly know about that. So if you're trying to make something about like climate change, but your art is like made, it's sort of like a landscape that's cut out of like vinyl or something, and it's like cut out of a material that's like very well known to be harmful to the environment, but you're sort of like engaging with the visual aspects as a way to have a conversation about climate change, then it's like that's kind of silly and it's kind of naive. And I feel like if that's what's like happening with the like use of electronics in somebody's work, then it's like I don't know, then I think it is kind of naive. But I don't think that like anybody should be told that then they shouldn't do it. Because like when I first started making work with electronics in it, I'm sure I made stuff like that. And I don't know, maybe I still kind of do. Maybe I am still kind of like learning so much about it that it's hard to say that like I like truly understand what's going on with it. But I don't know. I think it really depends on the work. I don't know. But actually, no. Now that I think about that more, at the same time, like I do know there's artists who I don't know. I feel like there's also a real stigma in like the contemporary art world against technology or something. Like when it comes down to like real bare bones electronics, like people in the STEM fields will write you off as an artist, and people in the arts will write you off as like, I don't want to say a gimmick, but like something along those lines. I don't really know. Like there is some sort of like weird engagement with it. Like I don't know if it's sort of like you know, Congress talking to Mark Zuckerberg situation where it's like they just don't know enough about it to have a conversation, and therefore like the engagement comes off as a write-off because it's just shallow engagement or something, or I don't know. There's not many artists that make like analog work that's aware that it's analog electronic work, I feel. Oh, come on. What's going on here? Yeah, yeah, I totally agree. Like making the work and like really going so deep. Like I don't know, one of the things that originally really drew me to going more and more analog with my electronic work was so that I could know like this capacitor is making this, work at this frequency, and like really really getting down to as far as I as like a cognitive being could comprehend how this sound was being made. And I feel like that definitely gives me a much deeper appreciation and connection with the sound coming out, but also the artwork itself. But I also feel like it's a trend for like many artists to have like assistants that are not considered part of the art. Like, because then you could say that I don't know, maybe the argument can continue to go just like deeper and deeper. Then it's like, oh, you didn't make the canvas. How can you appreciate the painting that you've made or something? But I feel like that's also just like a ridiculous rabbit hole to kind of go down. But I don't know. I also think it's like there needs to be a line drawn for sure, because it's like I feel like if you're a painter who the whole process is about, and the conversation you're trying to have is about the materiality of the paint, then I kind of feel like you should make your own paint. I don't know. All right, we are well into the first hour. I'm gonna start these. I'm running out of steam. I've been at work all day, and then I came here, and I'm having a hard time soldering. My hands are stopping to work. But we're close. I have one more wire to put in. And we're gonna plug this guy in, and then we'll do, fingers crossed, knock on some wood, a little demo using the modular system. Then I'm gonna eat some dinner, go to bed. There we go. All right. Very nice. Cool. All right, let's see. A lot of distractions. A lot of losing my train of thought. But we are here at the finish line. Let's see if we can cross it. Power. What if I had a power set up for it? Here it is. All right, moment of truth. There we go. Very nice. Now let's try it out. I need my little cheat sheet because none of these are marked, but I believe I want to make sure the inputs and the outputs are correct. Let me just open desktop 3. All right, let's see. Slow program moving. Show layers. All right, so we've got input CV output. That's easy enough. In CV out. I didn't have this paper prepared. So we are going to take some cables. This is the fun part. And we're going to route to the input. So what's going to happen is we're going to put an input in and then there's only going to come out, much like a faucet, there's only going to come a signal out when we put voltage in here and tell it to open up the faucet, so to speak. So I'm going to put a triangle wave in. Simple enough. Let me move this glass of water from the electronics. All right, so there's that. I'm going to turn the amp on. Nothing coming out. And then we're going to go to the output, and there's nothing coming out, but there's something hooked up to the input. Well, that's because the faucet isn't open. So I'm going to go to my LFO, right, which is just this blinking light. And when the light's on, that's when we're going to be getting voltage out. So let's see. Let me make sure the Twitch is picking up. Yeah, we're still picking up. Here we go. Let's see, I want a different signal. What's going on here? Yeah. So this is a pretty... I can go a little bit faster. And if I want to, I can put another audio source in and start experimenting with like AM modulation, like using one to modulate the other, and then it's going to become a totally different sound. So let me try that. So now I'm going to put a different triangle wave in. So you can hear it's it's a totally different thing. This is what it should sound like. And it goes from that to it's like a totally different soundscape. And that's because I'm using, one sound source, in this case a square wave, to modulate when the triangle wave is sort of like coming in and out. And so you can imagine what's happening here when I'm using the LFO, whenever the light's coming on, that's when we're hearing the sound. And so we're doing that so fast at such a high frequency with the square wave that it starts to modulate it into a totally different sort of spectral frequency of sorts. And yeah, what else can we do with a VCA? That's kind of like the main thing. We could do like, one VCA into another VCA, and then we have sort of a AND gate, which is just like a sort of way of logic where you say like, I need this and this turned on to hear anything. So if I feed the output of this one into another one, and then let's say I have a second LFO that's like at a totally different tempo, unrelated to this one, then whenever those two are on and they sort of, coalesce that way, that's when we'll hear a sound or something. Yeah. What else can we do with it? I don't know, let's just play around with it for a little bit. So I'm going to go into the clock divider now. And you can hear when I adjust the knob, we get like a different sort of amount that's coming through. It gets louder or quieter. Maybe I'll go like this to a mixer. Move this a little bit closer. because I don't have that many long cables. Plug this guy in. Input CV, okay. Something shorted. Oh, I see what shorted. Oh no. Yeah, there you go. Sometimes it shorts. Yeah, I shorted it. I think I blew the power supply. Oh no. Okay, we'll cut it there. Let's see. What was it? So that shorted. This smells like it's smoking. Yeah. Hopefully we didn't burn the power. No, that smells fine. Yeah, something they won't tell you is that smell is a huge resource when it comes to making electronics. Let's see, maybe I can unplug these and... Okay, that sounds good. It looks like I may have burned out the power supply. That's too bad. I might be able to swap a part out or something. Ooh, yeah. Oh, yeah, that just gave out. Did it? It looks like the positive end is having a hard time. Okay, well, for argument's sake, we can just swap this board out, which is still working fine, with my onboard VCA. And I can say output of this. What was that? Something just popped. Something's going nuts. We're going to unplug this. Oh, yeah, that stinks. I see the output of this. We're going to go CV. We're going to go input. No? Did I do that wrong? Input. CV. Yep. Output. 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 CV. Input. Input. Triangle. CV. Now, why is there no sound? there you go. I think that's a good place to end it. Yeah. Oh, good night. Yeah, good night, Andres. Thanks for tuning in. All right, for those of you still here, thanks for joining. Thanks for joining on Instagram Live and Twitch. Hopefully, we'll be back soon. I think Clock Divider is going to be next. But yeah, we'll see. All right, have a good night.